Hey guys, welcome back to another video of Math Mitchell. Today we're going to go over forms of linear equations. So there's three main types of linear equations you need to know. The first being the forms in which you can find them in. The first being the Y-intercept form, which is what we've covered before, which is in the form of y equals mx plus b, which were in previous videos showing how to graph and what it means. The second form is going to be your point slope form, which is going to be y, usually written as y sub 1, in parentheses, equals m, in parentheses, x minus x sub 1. We'll discuss that a little bit later. But first I want to touch on standard form. So standard form is our last and third form, and that's usually written with like an a x plus b, which is not the same b as a y-intercept, but you can write it that way, equals c. So we'll discuss each of these in details, but first I want to start with the y-intercept. So I'm going to go through this kind of a little bit faster because we've already touched on this a little bit. But as we've seen before, our y term is right here. This is sort of the end result of our linear equation. So we usually know x when we try to find y. But the biggest thing with this form is that we already have our slope, which is our m, and we already have our y-intercept, which is our b. And then of course we have our x here, which is x and y are our variables. So these are variables. There. Okay, I'm not gonna fill that out. I'm gonna just have it be there. My computer is lagging. So that's just gonna be v, and then your m and your b are gonna be constants. So I'll just have to put c there. So that's basically, it's a really simple form, and most of the time, or all the time, you can convert point slope and standard into y-intercept, and y-intercept is going to be the easiest one to graph. So if you want to graph a linear equation, having it in the form of y-intercept or mx plus b is going to be your easiest, because you just use your b to find your first point, and then use your m to find your second point, like we did in the other video, and you're all good. So I'm going to move now to point slope. And if you want examples of y-intercepts, there's other videos, or I have previous videos where we use examples of y-intercepts. But the point slope is a different form that you may encounter, and I'll give you examples here. You're going to have, so y is going to be your variable minus some constant like 2 equals m, which is going to be some slope, and let's say 3, and then x minus 1. So that's an example of a point slope, and basically it's really easy to put a linear equation in this form. You'll see this later in algebra and algebra 1 and algebra 2, but it's really easy to put in like just a point and a slope into this equation. That's why it's called point slope. Mainly because you're going to be given a point like 2, 1, and you're going to be given a slope of 3, and you're going to be asked to find the linear equation later. And this is a really easy way to put it in there, because it's just the opposite of the y term. So I just realized that this is an incorrect comparison. You're going to be given the you just insert the y term there, and the x term there, and the slope there, and then you can convert it into y-intercept to graph. So it's really easy to do that. And point slope is really helpful for also converting, because all you have to do is multiply the 3x, so you get 3x. And then you multiply the 3 and the negative 1 to get negative 3. And that equals y 2. Sorry, and lighting here. And then if you bring the 2 over, then you just get y equals 3x minus 1. So, and then there's your point slope. So that's your y-intercept. So you can convert point slope really easily to y-intercept. Now the last one, standard, is basically a neat way to put a linear equation into a form. But if you wanted to convert this, also remember that this term is also going to be positive. It's always going to be positive. So if you have a negative term there, you got to divide it out by -1 to get a positive term. But to convert this to y-intercept, say if you want to graph it, usually when you're going to encounter standards, they're going to give you a standard problem, and you have to convert it to y-intercept because you want to ultimately graph it. So you're always going to subtract the a x from both sides, and so then you get b y. Remember, like I said earlier, b is not the same thing as the b in the y-intercept plus c. And you're going to divide. That is not a c. Then you're going to divide out by b. Then you get y equals, in this case, is using variables, but or I'll explain here in a second which ones are going to be variables and which ones are going to be constants. As you can sort of tell, the A, B, and C are going to be constants. So B and C are all equal to, C constant, and then X and Y, or Y and X are going to be variables. So same here, the Y1, sorry, I didn't touch on this here. The Y1 is going to be equal to a constant. X1 is going to be equal to a constant. M is going to be a constant. And Y and X, are variables. That's a little sloppy. But basically, you need to know the 3 different forms and how to, most of the time, convert them to y-intercepts so that you can graph the actual linear equation. But these are the 3 forms you're going to see them in, and that's how you convert them, and that's what they mean. So they're all linear equations, but they're just in different forms.